Hi, my name is Peter Murishkin, speaker of SIGSPL.org. Today we will talk about what is going on this world and how do rabbits, transistors and smartphones relate with disruptive software businesses. Well, what can I say from observing the world? That many people actually do not know what is happening, because there are so many new technologies. Every new year coming a new smartphone or a drone, and all this is happening so fast, so that they say also we are in the exponential age or information age. So I'm going to talk about this and share my thoughts with you. So maybe you know all these did you know videos. One of them has collected 2 million views. So maybe you have known some things, but let's start with exponential times. So if you already know, then just skip a couple of seconds. But for those who have slept in a math lesson, so exponential is basically doubling over time. This means that if you have got 2 rabbits and let them do, then after 18 months you have got about 200 rabbits. So this means that having rabbits is a doubling function which is exponential, and then there are also linear functions, like getting salary. This is basically linear. So what is special about exponential function is that at the beginning it is going very slow, but then there is a jump. And this jump is probably what is going to happen next years. So living in exponential times means basically that we have got an exponential growth in technology. So as you can see, these guys in Stone Age, they used their Stone X10 for 1 million of years without modification. But then, like 600 years ago, we got our printing press, then 1850 telephone, and then it goes like whoosh in the last 50 years. Starting with microprocessors. So we will see what is special about microprocessors. So then also, if it goes like this, then actually by 2020 it would mean that there are dramatic changes or anyway new things happening weekly. And even today, each day I learn so many new things that I'm really amazed, but also sometimes scared at the pace how it is going. So, what happened as microprocessor was introduced? At the very beginning was a transistor. So this is actually all what these guys are talking about Moore's law, about singularity. So you have looked up already probably Ray Kurzweil or Peter Diamandis. So basically the whole thing about it is the technology growth of microelectronics and computational power is that our microprocessor devices, they are getting smaller, there are more of them, and they're getting cheaper. This means that, well, it is quite a funny thing, because we are not yet there to have a computer which is as powerful as a mouse brain, but due to the exponential function, this whoosh, maybe we will close the gap to human brain in a couple of years. So this is about hardware, but what is about software? Let's see what has happened since the beginning of the microprocessor. 46, these were programmers. They connected different units of the computer ENIAC. This was maybe your grandma. Then your father worked as a programmer, and he worked also at some terminal, also basically busy with inputting digits, 0 and 1s, like codes. And then there was a paradigm shift. They moved to a screen, which has been done also by the SAP guys. And then today, 50 years after first computers, we still have got people who do manual job in moving around ones and zeros. So where is the exponential growth in this area? Let's see for some more technical background. There are quite many programming languages. Most popular of them are Java and C and C++. So Java being like 25% of software being written. So if we have a look just at Java, because it is at least what I really know, then since 2004 there is some standardization ongoing. So there you find the exponential growth. So in 10 years we have now about 1 million and more standard Java components. And maybe you haven't heard of this component repository, but still there are some guys who write software, and there are guys who run this repository. They say that they have got 17 billion downloads a year, and they expect this to double. There are two big repositories like this, maybe others, but I do not know. And this is actually disruption of programmer work, because you do not need to invent the wheel. You can just pick up some components from the million of standard components, what they do also. And then there is Docker since last year, also booming. There is also very fast pace, 1 million of standard Dockerized apps, and this actually disrupts the system integrator work, because even if you do not run Docker in your production, you can use it as reference testing application. So here you've got the exponential growth and also the disruption. But what does this mean? This means that IT departments out there, those guys who download 17 billion components a year, they glue 19% of software from free components. And then it means that any commercial software, or big part of it probably, can be a hidden mixture of standard components. So it is like coffee. These are more or less same coffee beans, but you can pay for different flavors or brands. And then it is to expect that as the basis of this is the same mix of components, then there are similar risks and problems across many IT departments. They are often invisible due to the silos, because people are ignorant. But still, this boosts inefficiency and waste, and therefore is subject to disruption. And then there are also interesting questions arising from that, namely, what is the real USP or intellectual property value of commercial software brand if I use 90% of standard free software for that? And then how can I manage all those Internet of Things and Industry 4? How is about quality and sustainability if there is a million of components which are ever changing? And who is in charge to take responsibility? And finally, what is the quality of this million of software components? Actually, there are some invisible facts. This is what we know about most software components out there. Of course, there are popular, like from Eclipse or Apache Foundation. They are just well known, so it is like usage by recommendation. But still, if we would look on some invisible facts, we could find out that some components are like A++ and some are not. And this is a measurable issue. Therefore, what if we would build an automated digital certification system for available software components, following the energy label visual, saying, let's define something which is very, very good, which is today maybe not affordable, but this is like A++. And then, let's say, if I run a code which does not compile, maybe it is beautiful, but computer cannot understand it, so it is G. And then the range between it will be a huge impact on competitiveness of companies. So why do this? To make quality not matter of discussion but standard. To know which risks you buy in with free software or not free software. this is equal. Or to know which intellectual property you pay for if you invest into some specific brand, because you would like to know which components are in the mixture and the flavor you buy, what are coffee beans you buy, and then also to separate the good from the bad. And of course this can be done on many different dimensions, which we will address in later videos. Well, this idea has been presented to European Commission by members of our open public think tank. We are special interest group. We are special interest group for software production lines. Software production lines to build IT that rocks. And our vision goes even beyond that. We say that we can build new information technology following DevOps, Lean Six Sigma, and big data paradigms, or concepts. We can deliver industrial augmented reality, virtual reality tools for programmers like this. We can visualize the whole value chain for all stakeholders across the IT company. And we are going to introduce a new cognitive approach based on human perception to information technology, namely labor automation, analysis, and arts. Well, so our SIGSPL's mission is basically to leverage modern industrial quality assurance to the software engineering of 21st century to build IT that rocks. You can find more information and articles at our blog. Then let's round up. Stay tuned and win a book. Teaser. In next video I will talk about industrialization of software technology. We are going to get more serious than talking about rabbits and focus to what could be Internet of Things 2.0. What are methods and existing tools? And funny enough, but our statement is that these concepts, so actually having a transferable and measurable quality of information technology, is a crucial precondition to build Industry 4. So let's play a quiz. Why do we at SIGSPL.org call Kosciuszko Kawagachi the Henry Ford of 21st century? Send your correct answer to this stream ID and you can win the book which will change your life, and it really helps you to achieve outbreaking performance. And actually it is a funny story but about serious things. So these are the guys, Kosciuszko Kawagachi and Henry Ford. Yeah, and I would like to finish with two quotes, namely, our future prosperity depends on the quality of our collective imagination. So let's imagine new things. This has been said by Eric Ries. Now, thanks for watching. This has been presented to you by SIGSPL.org. Let's now build the rocket science idea. Thank you very much.